Hello students, today we are going to start a new part of electrostatics, that is electric field. So before going into the video, please have a book and pen so that you can write down some important points or notes so that you can refer later again. And along with this video, you can see the assignment in the description box. I shared the assignment also. At the same time, in the description box you will find Facebook page. You try to follow it so that you will get all updates related to this channel. And you are watching my JEE Physics channel, and I am your Anant. Now we start. Let's get into the video with electric field due to point charges. So if I am having a 1 point charge, so then what is the electric field around it? What is the electric field magnitude? So those things we are going to see. Along with the electric field due to charge, we are going to see the electric field due to continuous charge distribution. Something like so don't worry about this big word continuous charge distribution. It is simple that it's a charged object. Continuous charge distribution means charged objects. Okay, so that is the meaning. So these are the two things we are going to see in this video. So let us start with electric field first. So what is the electric field definition? Electric field definition is something like a place around the charge in which it can attract the other charges. So if I am taking a one charge plus q, okay, at a fixed point, then there will be some space around it. Around this charge, some space will be there. If I am keeping in one more charge over here, okay, so then this charge will experience repulsive force by this charge, by capital Q. If I am keeping the charge over here, it does not experience any force, so then I say that force is 0. So the region in which the other charge is either repelled or attracted, then that region's place is called as electric field. You can compare something like within cricket field, okay, so where cricketers are present, the cricket field, cricketers are present, okay, so the region, place is called as actually field. Here also, around the charge, some space will be there, okay, place, region will be there, in which electrostatic force you will find. So the place where you will find the electrostatic force is called as electric field. And remember, these are not textbook definitions, these are only definitions to understand the concept, okay. So for proper definition, you have to follow the textbook. So I am not getting into that details first. First we try to understand all the concept, okay, and we learn techniques to solve the questions with this video. Now, so supposing that this is the place where other charges can be attracted or repelled, then this place is called as what? Electric field. So electric field is a region in which other charges can be attracted or repelled. Okay, just I wrote definition. If you want, you can write down. You note it down this definition. Okay. So once a field is done, then problem will come with this. Suppose if I am keeping a one charge q, so there will be place or region around this where if you keep any charge in this region, that will be attracted or repelled. Now the question is, suppose I am taking the one point A, which is at a distance of R1. R1 is the distance of A point. Now I will take the B point at a distance of R2. I am taking two different points in the place. So if I am keeping the charge plus Q at A point, so that will be repelled. Even if I keep the charge at B point, that also will be repelled. So both the charges, whatever charges I am keeping, this is fixed charge. And we are finding the field due to this charge only. This is our reference charge. Okay. So we are calculating related to capital Q, not small q. Small q is our test charge. Means we are testing everything by keeping the small q. Okay. So at A point, B point, both the places, that charge will experience the force. But what is the difference? There should be some difference between A point and B point. Okay. That difference we need to define, or the difference we need to explain also. Okay. So for that, they come up with one more word or one more naming, that's called as electric field intensity. Okay, so in this video you will find two terminologies. One is called as electric field. Electric field is nothing but it's a place or region, that's it. But the second important thing for us is electric field intensity. What is the meaning of electric field intensity? That I will discuss, which we call it as, sometimes I call it as electric field value. Okay, electric field magnitude. Electric field magnitude means only magnitude it will tell you. Electric field value, again magnitude only. But electric field intensity will tell you magnitude as well as direction also. It's a vector quantity. Usually it is represented with E bar term. E bar is the representation of electric field intensity. And similarly you will get gravitational field intensity also. Entire this chapter is a replica of gravitation chapter. Okay. So whatever you study here, little changes will be there, and so that you will get the gravitation part. So let us go on to what is this electric field intensity, how it is defined as. So to define the electric field intensity we require the positive charges. So people defined with positive charge, we need to do with the positive charge only. Now at A point I want to go with electric field intensity. Remember again one more important idea for this. Electric field intensity is defined at a point. Means it's a point property. So in the field, if I talk about, because I told you no, at A point force will be there, B point also force will be there. But there should be some difference between A point and B point. So at A point the property is different for the field, at B point the property of the field is different. That difference is explained by using electric field intensity. That's why this purely defined electric field intensity at a point. Now how it is defined at a point? Okay. Now I am taking that Q0 is my test charge. Now I want to identify that electric field intensity at a point. Now what is the test charge I am taking? Q0. What type of charge I am taking? Plus Q0. So here positive is reference charge they have given to us. So they define. So you see any book in the world, physics book related to electric field, that is defined with the positive charge only. So whatever results we are going to get, that all depends on the charge nature, which is positive, okay, which is related to positive. Suppose instead of positive if I am taking negative, then what happens? So whatever results we are getting, exactly reverse result you will get for negative charge. So first we will get into this concept, then you will understand if I am taking a negative charge what will happen. That also I will explain, okay. So how the electric field intensity is defined at a point? It is defined as, electric field intensity at any point is defined as force acting on the charged particle whatever you are keeping by the charge magnitude whatever you are keeping. That means here the charge I am keeping as Q0. Then here this Q0 will experience some force, that force value by the charge, whatever test charge you are keeping, the test charge magnitude. So this is the definition of electric field intensity. Now let us see what is electric field intensity at a point. Okay. So this is fixed, I told you, this is fixed charge. Because of this charge only I want to find out what is that electric field intensity at a point. So then I am keeping the plus Q0. Then this plus Q0 will experience repulsive force because positive and positive. So this is the force direction. Then what is the force magnitude? The force magnitude I can write down something like this. The force magnitude is equal to 1 by 4 pi epsilon naught. Again I am taking vacuum. Okay. Q into Q by distance between them is R1. So R1 square. This is the force magnitude. So then what is the electric field intensity? Intensity vector is defined. Now I want to find out electric field intensity magnitude. The electric field intensity magnitude is given by something like this. Force magnitude by Q0. Vector is E bar is equal to F bar by Q0. Then whereas E bar magnitude is F bar magnitude by Q0. So what is F bar magnitude is this much. So charge is Q0. So here it has to be Q0. Then Q0 by 4 pi epsilon naught R1 square by Q0. Force magnitude by Q0 I wrote. Then Q0 cancel out. What is the field intensity at A point? Magnitude is 1 by 4 pi epsilon naught, okay, Q by R1 square. So A point is at a distance of R1. I got Q by R1 square is the field electric field intensity magnitude at A point. Then as this is a vector quantity, So we should know the direction of E bar also. Then here if you see the formula directly or definition directly, then E bar is F bar by Q naught. Q naught is not having any direction, it's a magnitude only. Then F bar direction, E bar direction should coincide, because we know that in mathematics A bar is equal to some B bar by, suppose, some number X, then B bar direction and A bar direction is same. Whatever B bar direction will be there, that should be the A bar direction. So similarly, whatever F bar direction is there, that should be the E bar direction. Okay, so then F bar direction and E bar direction is same. So what is the E bar at A point? E bar at A point is along the line joining the point and charge and away from the charge. Similarly, I am taking the one more point B. B is at a distance of R2. Then how to find out the field at B point? Now it's direct. Otherwise you can take Q naught. You place the Q naught, identify the force. Okay, force by charge will give you field. In other words, what we have to do is electric field intensity at B point, magnitude. I am writing electric field intensity at B point, magnitude is 1 by 4 pi epsilon naught. Okay, for what charge you are calculating? Charge by the distance of the point from the charge square. Just I am replacing R1 with R2, nothing else. Because if I am keeping the Q naught, into Q naught will get by Q naught. Q naught will cancel out. So no need to write down. So 1 by 4 pi epsilon naught, charge whatever you are taking, or for what you are finding the electric field, by distance of the point from the charge square. That will give you magnitude of electric field intensity at a point. Okay. So if this is the magnitude, then what is the direction of the field? As I told you, if I am keeping one positive charge here, that positive charge will be repelled. The force direction will be the field direction. So field also will be along the force direction. This is the field direction at B point. So from this I can make a one general principle, that is the field direction will be along the line joining of charge and point. Whatever point you are taking, whatever charge you are taking, if you joining those two with a line, along that line field will be there. If positive charge is there, field will be away. Okay. So in this way we can identify direction of the electric field intensity, and we can identify the direction, also the magnitude of electric field intensity also. So next we see that if I take positive charge, as we discussed earlier, if I take any point, random, I am taking the one point P at a distance of R. So we know that electric field intensity magnitude is at P point is 1 by 4 pi epsilon naught charge Q by distance square. And what is the direction? As it is positive charge, the direction will be radially away. You can take like this, direction of the field is always radially away for the positive charge. You take any point, if you draw the line joining the point and charge, then you will get radial line. Okay. So field direction is radially outward. You can say that field direction is radially outward. Okay. So this is the field nature for positive charge. So similarly, if I am keeping a negative charge, then there will be field around it again. If I take randomly one point at a distance of R, then also you will get the field magnitude at that point. At this point, field magnitude I can write down 1 by 4 pi epsilon naught into Q by R square only, because you don't find any difference. Again you keep a one positive charge Q naught, because I told you reference charge is positive. Then force is Q into Q naught by R square, 1 by 4 pi epsilon naught times of Q into Q naught by R square by Q naught cancel out, you will get by Q by R square only. There will be no difference in the magnitude. But where you will get the difference? You will get the difference in the force direction. Now, as it is positive charge and this is negative charge, the force will be attractive. Then, as the force is attractive, in the force direction, electric field intensity direction should be there. So, E bar also will be towards the charge. So, if I take any point, E bar will be towards the charge, because force is attractive. So, I can say that for positive charge, field is radial away. For negative charge, the field is radially inward. Okay. So, in simplest terms, layman terms, for positive charge, field is along the line joining, away from it. For negative charge, field is along the line joining but towards it. Okay. So, this is the field magnitude. Now, for this electrostatic field, or you can say that electric field intensity, it has a very important one nature, that's called as it follows superposition principle. Okay, so it is very obvious that it follows the superposition principle, because this electric field intensity we defined from the force actually. So I think you understood or you observed one fact, that this is simplified form of a what is that, electrostatic force. Electrostatic force we simplified into electric field intensity. So whatever be the force nature, the same nature will come to the field also, because it's simply divided with a number. So electric field is nothing but electrostatic force by Q. Q don't see as in charge, you see it as a number, then force is divided with a number, then you will get a field. Then what are be the properties for the force, same properties you need to get for the field also. So that's why, as force follows superposition principle, field has to follow the superposition principle. So what is the superposition principle in terms of electric field we see? Okay. Now I am taking one Q1 charge plus Q1 and minus Q2 I am taking here. Okay. Plus Q1 minus Q2. I am taking the two charges. You can take any n number of charges. And if I am taking the one point P, so this P is there in the field of Q1, even in the field of Q2. I have drawn the rough diagrams of the field. Okay. Means one field is superimposed on the other field. One field is present along with the other field. So both are superimposed. Both are mixed. Okay. So because of Q1 along the line joining, okay, field will be there, and that field will be away from it because it is positively charged. Similarly, because of negative charge minus Q2, field will be along the line joining, but negative charge field will be towards. So at P point E1 bar will be there, even E2 bar also will be there. Both the vectors are simultaneously present. This simultaneous presence is called as superposition principle. Even in last lecture also we discussed the lecture related to electrostatics Coulomb's law. Okay, lecture 1 for electrostatics. If you want, you can refer that video also. Okay. From that we can say that what is the net electric field at P point. Net electric field at P point will be the resultant of E1 bar and E2 bar. We need to add vectorially. I told you, whenever vector addition comes, there inherently superposition principle is there. Okay. So then what is the E1 bar and E2 bar? We can directly write down the magnitudes. What is the E1 bar? I can write down 1 by 4 pi epsilon naught Q1 by R1 square. E2 bar I can write down 1 by 4 pi epsilon naught Q2 by R2 square I can write down. So I know the magnitudes. If I am able to identify the angle between fields, then I can find out the net electric field at P point. So this particular thing is called as superposition principle. Okay, so this plays very important role in finding the electric field due to extended charges. So till now we have seen that what is the electric field magnitude and direction due to positive charge and negative charge. So let us see one important point related to this charges, that's called as null points. Null point or null points. What is the meaning of null point? Null point means the point at which electric field is zero. So wherever you find electric field strength or magnitude is zero, obviously electric field vector also zero at that place. So that point we call it as what? Null point. So now we see that how these null points can be identified. So sometimes they'll give you some charges and they'll ask you where is what is the point or position of the point where you find the electrostatic field is zero. So that point I am going to explain now. I am taking a similar type charges. You can say the first case, similar type charges. What is the meaning of similar type charges? I am taking the positive charge and positive charge, or negative charge and negative charge. Okay. So I am taking like this, plus Q1 and plus Q2. Okay, same type of charges. Or you can say that minus Q1 minus Q2. You can take either positive or negative. Now this is the line joining. Now I want to find out where you will find the net electric field due to these two charges is zero. Now first of all, entire space I am dividing into three parts. One is above the charges, other one is below the charge, and on the line joining the charges. Okay. So if I take randomly any point above the charges, so do I get net field value 0? Okay, so that is the question. You can think about it. So net field is 0 or not? See, because of plus q1 field will be away from it. Because of plus q2 field will be away from it. So to become net field 0, first of all they have to cancel each other. For that they have to be opposite to each other. Whenever two vectors are opposite to each other, okay, so if their magnitudes are equal, then they will cancel out. So what is the primary condition for cancelling out? First of all, they should be opposite to each other. But here, you take any point above the charges, you don't get fields are opposite to each other. That means you don't find any null point above the charges. Similarly, you don't find any null point below the charges also. You take any point because of plus q1 away, plus q2 also away. So E1, E2 fields are not opposite to each other. So you don't get any null point. So we have only one choice, that is on the line joining. On the line joining only we will get a chance for null point. So let us see. First I am taking any point on the right side of the charges. Completely right side of the charges. If I take a point on the line joining, then because of plus q2, field will be away from it. Because of plus q1, field will be away from it. So now both the vectors are in the same direction. Means fields will add up. They don't cancel out. That means on the right side also we don't have any choice to identify the null point. So similar case you can think from minus q1 minus q2, then fields will be towards, then also they will add up. Okay. So this is, I'm not only deriving for positive and positive, you can think from negative and negative also. Okay. So here there is no choice for field 0. Suppose if I am taking the extreme, left of two charges combination, again because of plus q1, E1 will be away from it. Because of plus q2, E2 will be away from it. So again they will be add up, both are in the same direction. So on the right side you don't get null point. On the left side also you don't get null point. On the above the charges, line joining the two charges above, there is also null point, below also no null point. So definitely we have be left with only one reason, that is in between the two charges. Okay. So if I take any point in between the two charges, that point I am taking as P, then because of plus q1, field will be away from it, E1. Because of plus q2, field will be away from it, E2. Now these two are opposite to each other. Then there is a chance for they cancel each other. I am supposing that this is x1 and this distance I am taking as x2. Okay, so E1 value I can write down. E1 value is equal to 1 by 4 pi epsilon naught. E1 is because of q1. q1 by distance of the point from the charge is x1, so x1 square. This is E1 value. Similarly, I am writing as E2. E2 value is equal to 1 by 4 pi epsilon naught q2 by then what is the distance of the point from the charge is x2, so x2 square. So these are the fields. They are opposite each other. To get a null point, they should be equal to each other. Whenever they are equal to each other, then we will get a net field is at p point is 0. So if E net at p is 0, okay, net field at p point is 0, that means E1 minus E2 should be equal to 0. That implies E1 is equal to E2. Okay, so once E1 is equal to E2, so I am writing here expressions. E1 is equal to E2, then I can write down 1 by 4 pi epsilon naught q1 by x1 square is equal to 1 by 4 pi epsilon naught q2 by x2 square. 1 by 4 pi epsilon cancel out. Then q1 by q2 is equal to x1 by x2 whole square I can write. Okay, you can check. q1 by q2 is equal to x1 by x2 whole square. So from this expression I can write down q proportional to x square. So what I want to express from this is, if q value is more, x value will be more. That means if q value is less, x value will be less. So point will be closer to lesser magnitude of charge. So what is the conclusion I can write down? The conclusion is null point will be closer to lesser magnitude of charge. So whichever charge is having the less magnitude null point will be close to that point, and at the same time in between the two charges. Even if you are taking a minus q1 minus q2, then fields will be towards q1 E1, towards q2 E2 will be there. So again they can cancel each other. You will get some relation. Okay. So remember q proportional to x square idea whenever you are getting the positive and positive charge. So we see that case 2. Okay, we have seen the similar charges, then how to identify the null point. Now I'm taking that unsimilar, you can say that opposite sign charges. If I take positive charge and negative charge, then how to go for that? Suppose I'm taking the plus q1, okay, and okay, let me take here plus q1 and minus q2. One is positive charge, other one is negative charge I'm taking. This is the line joining. I think till the discussion you can understand that you don't get any null point above the line and below the line. You take any point above the line, you will get field directions are different, not opposite. We need to get opposite first. Okay. So let me check in between the two charges because already we got. So that's why I am checking here. If I take any point in between the two charges, then because of plus q1, field will be away. Because of minus q2, field will be towards. Because of negative charge, field will be towards. Positive charge, field will be away. So again, E1, E2 will be in the same direction. That means you don't get null point in between the charges. Then you will get the null point either on the left side or right side. It depends on the charge magnitude. So let me talk about one point on the left side. If I take this point, because of plus q1, field will be away, and because of this charge, field will be towards. Okay. So similarly, if I take one point on the right side, because of negative charge, field will be towards. Because of positive charge, field will be away. Okay. So here there is a chance for null point. Here also there is a chance for null point. But to get null point, there is one more condition, that is E1 should be equal to E2. Okay. So now let us write down x1, x2 logic again. Suppose this I am taking as x1, this I am taking as x2 distance. I am supposing that this is the point where I am getting the net field 0. So net field is 0. That means I can write down E1 is equal to E2. So I can write down 1 by 4 pi epsilon naught Q1 by x1 square is equal to 1 by 4 pi epsilon naught Q2 by x2 square, because I am writing only magnitude. Q1 by x1 square, Q2 by x2 square. Cancel out. Then again I will get Q1 by Q2 is equal to x1 by x2 whole square. So this stands for Q proportional to x square. So again same logic, if x value is less, Q value will be less. Okay, proportional. So that means null point will be closer to lesser magnitude of charge. So if I take like this, plus 2 microcoulomb and minus some 6 microcoulomb, random I am taking. So if I take this is a combination, the null point will be on the left side because closer to the lesser magnitude of charge. Suppose if I am taking like this, plus 8 microcoulomb and minus 2 microcoulomb. Okay, so then what is the null point? Null point will be closer to the lesser magnitude, means somewhere on this side. Okay, so like this you can identify the null points for given combination of charges. Whether similar charges are given or opposite sign charges are given, you can identify the null point by using this logic. For both the cases, you can apply Q1 by Q2 is equal to x1 by x2 whole square. But check whether null point is in between the charges or left or right side the charges. I am making other video related to field due to continuous charge distribution because it is becoming so lengthy. Okay, and after this lecture, like field due to only point charges, so I will make one more video related to questions or problems, numericals of the same topic. So you will get like one topic, one video on theory, and the next video will be on the problems. So like this theory and problems one in sequence wise, you will get all the videos. Please follow video by video so that you will understand better, and please write down all the important points wherever you like. And if you like any point of the video, please don't forget to hit the like button, and please subscribe the channel to get more number of videos and updated videos also. Okay, and for your convenience I am keeping in playlist after the end of the video. So in that playlist you can see all the videos related to same chapter. And remember, in the description box I am giving the assignment, so you can directly download, which is from the Google Drive. And you can identify the Facebook page also in the description. So please follow that Facebook page so that you will get the updated news related to this channel. So signing off today, and this is your favorite channel, my JEE Physics.